gave you this problem. If you wanted to solve that equation, what would you need to do first? Distribute. What am I going to be distributing? A 3 and a negative 1. Okay. So I would get 10 plus 6x minus 12. And over here it would be what? 17. Why don't we clean it up just a bit and combine like terms on each side? So over here I could do, since they're on the same side, you don't have to subtract 10. You're just adding 10 plus negative 12, it's negative 2. Okay, over here, just adding, so 17 minus 5 would be 12 minus x. Then what do we do? And then? Okay. Divide what?
Divide the 7 and then 14.
And we get x equals. Is there a way to check your answers on these? Good. All we have to do is go back and plug it in. Alright. Any questions about that? Yeah, solving equations. Mm-hmm. It's a good day.
Yeah, it's
Alright, we ready for another one?
Yes, we are.
Good answer.
If it's challenging, I'll
I didn't say that. Now, this one isn't all that bad. Okay, we have a couple options here. So let's talk about our options and decide what we want to do. Well, I guess we really have 3 options. Ava?
I don't know what I was going to say. Would we be able to just, because if it's adding, they don't have to be like everything denominator, do they?
Yeah, it's when they're multiplying that you don't have to do the same denominator. So option 1 would be to get a common denominator and add these things together.
Option 2, could we just multiply by 6 to the other side and then multiply by 2 to the other side?
Yeah, option 2 is multiply to get rid of all of our fractions. Option 3 is just to get over it and deal with the fraction. You know, you can split this up in x over 6 plus 7 over 6 and deal with that. So,
I don't like option 3.
you don't like option 3. So do you want to get a common denominator or get rid of the fractions?
Get rid of the fraction.
Get rid of the fractions. You okay there?
She's going to pop them back.
Oh,
yeah.
okay.
Sorry. Well, now I'm
So, if I want to get rid of this fraction, what would I multiply by? 6. And when you do that, just like we did with the uglier stuff, you have to do that to everything, right? So here, those 6's drop and you're just left with x plus 7. Right here, can't I reduce 2 and 6? And that would just give me a 3. So if I distribute my 3, I get 6x minus.
Will you do that again?
Yes. Okay. Let me back up a step. So we were multiplying by 6, right? And what I did first was said, well, let's look. I have a 6 divided by 2, which is 3. So really, I'm going to take that piece times
So you don't have to multiply the two. They can.
I don't have to on this one though. Now if it didn't cancel out, then we would.
Okay.
Over here, negative 4 times 6. Alright. Now, do you feel better about this one? Yeah, it should be pretty simple from here. Combining like terms, if they're on the same side, you just add them together. So we have a 7x. 7 minus 24. Add our 17 over. Divide by 7. And x is negative 1. And could we check that if we so desired?
Yes.
Yes, absolutely. We just have to go back to the original and plug it in. Alright, well that wasn't that bad, was it? Okay. Ready for another one?
Yeah.
I'm going to put a couple up here that I want you guys to try. Okay, make sure, I think it's worth the time just to write it on every single term. It helps prevent some mistakes. In the first ones, we see those both cancel, so all you have left is the x minus 2. On the second one, 4 divided by 2 is, so I'm left with a 2 to distribute through there. And over here, 1 times 4 is 4. So I have x minus 2 plus 2x plus 2 equals 4. Combine like terms, so we get 3x, my 2's cancel, equals 4. Divide by 3 and x is 4 thirds. Are there questions on that? Look at the second one. Where do you begin?
You don't. You just write it out.
Okay, starting on the inside. I put this one here because here is what I normally see on a problem like this. People distribute that negative, and then they put negative 5 times 9 minus 2x. What is wrong with that?
That's why I did that.
Yes. When you have negative 5 minus this principal, that's like negative 5 plus a negative 1 times that. You only distribute the negative 1. There is still an addition sign right here. Over here, if I distribute my 3, I get 6x minus 2. Okay, so if I, actually, let's not distribute it. Let's combine my terms in here first. You could go either way, but negative 5 plus 9 would be a 4 minus 2x equals the 6x minus 2. Distribute my negative 3, so I get negative 12 plus 6x equals 6x plus 2. What do we do now?
Yes, 6x minus.
Thank you. So if I subtract my 6x, those cancel, and I'm left with negative 12 equals negative 2. I saw someone else that had like 10 equals 0 because they added the 12 over to each side. What do you know right now? Not possible. So this is a no solution. If you solve it and you get a false statement, it is no solution.
I don't even know what it is.
All right. Questions there?
Why wouldn't you use
right here, you'll get the same thing. You would have 15 minus 27 plus 6x, because you have to distribute the 3 to all 3 of those.
Oh, okay, that's what I did. Because I got 13
Any other questions? Let's do this one.
Okay.
So what about this problem makes you groan? Decimals. What tool do you have at your disposal? A calculator. So is there any reason to freak out because it gave you decimals? No, absolutely not. We can do this. What's my first step going to be? Distribute.
Is that a 15 minus
Yes.
Yes.
actually it's 13?
So if I distribute, I have my 0.09 times 15 gives me 1.35 minus 0.09x. Then I have my 0.07 times 15, and I get 1.05.
Okay, we're gonna add like terms now.
Okay. So if I add those, I get add the negative words each other. So we get negative 0.03x. And then what?
Okay, now you're gonna subtract your 1.35 over. Is that what you just said?
I didn't say it, I was just writing.
No.
So then what do we get? And then what? Divide by negative 0.03.
That was such a
And we get what? 10.
How does that happen? I don't like math for that reason. Like what?
You don't like it because I gave you something with a pretty answer? Really?
Like,
How
was that 10? That just doesn't make any sense. It doesn't add.
You have 0.3 of cookie.
Yeah. I got 3 tenths and divide it into. Okay.
You explain this math problem to cookies.
We're going to make cookies and do cookie math. Alright, so the reason you get 10, think about when you did long division with decimals, you would move the decimal off, so you'd have to move this one 2 places over to make it a 3. So if you move this one 2 places, it's 30. So 35. Okay, so what we've seen, well, we haven't seen all of them yet, but we will. We've seen 2 different types of problems. We've seen problems where we get an answer, and we saw one where we didn't. There was no solution, right? All of our linear equations fall into 3 different categories. The one that we're used to is when you get an answer. That's what's called a conditional. It would mean if you graph these 2 lines, they are going to cross somewhere. So conditional, you get one answer and only one answer. If it is a contradiction, that's the one where we get no solution for our answer. What that means is, in terms of the lines, they had to have been parallel. They will never meet.
So,
Okay, we're talking about solutions to linear equations. So linear equations mean graphs of lines. If you get no solution, that means you have 2 lines that never meet, so they had to have been parallel lines. And we call that a contradiction. The third type, we haven't solved one yet, but there is what's called an identity. And what that means is I gave you 2 equations for the same line. So if you were to graph them, they would be the exact same line. What we see on these, there are infinite solutions. Basically, every point on that line would be a solution to the equation. So those are the 3 categories. If I ever ask you to classify it, what you do is solve it, and then you classify it based on your answer. If you get x equals a number, that's a conditional. If you get no solution, that's a contradiction. If you get an infinite number of solutions, that is what's called a conditional. Sorry, I said conditional, I meant identity there. Alright. So what we're going to do is just practice a few more to wrap up for today. And I'm going to throw the extra directions here in. Those are really tiny. We are not only solving these, we are going to classify our answer. So this first one, what would we do? Distribute. So we get negative 2x minus 8 plus 3x equals x minus 8. Then what? I like negative 2x and positive 3x is just a 1x minus 8 equals x minus 8. What happens now? What should I do? If you subtract your x, you're just left with negative 8 equals negative 8. All my variables canceled, and I got a true statement, right? Negative 8 is equal to negative 8. This has infinite solutions, all real numbers. This is what we call an identity. So you could say all real numbers, you could say infinite solutions. I did also ask for the classification, so it is an identity. Any number you pick would work there. Because you got to this point, my x's are gone and I'm left with a true statement. That means no matter what x was to begin with, it will work out. Alright, why don't you guys try a couple here? Oh, let me do that. Why don't you guys try those three? So on B, you got 3. How do we classify that? Condition. It's true under the condition that x is 3. Okay, C, if you distribute, if you subtract your 9x, we have negative 3 equals 7. What do you know right now? No solution, contradiction. Okay, the last one, if I subtract my 4x, I get 2x. If I add my 9 over, I get 22. Divide and you get x to be 11. So what does that mean? Alright, are we okay with this? Good. So you could have also had 0 equals 10, and that's true. Well, yes, it's a false statement, but also a correct solution here. So, the assignment is on Math Excel. It is posted, due at 3 o'clock tomorrow. Just make sure you are remembering if you do work any problems for late credit, so if you work it after the due date, you have to tell me to go in and update your scores. I don't go back and check after I transfer them over to SIS. I don't just keep going back in to see if anybody's worked anything else.